Okay, let's talk about transformations. And simply put, a transformation is when you change a shape from its original to an image. And there are 4 types of transformations that we're going to talk about and we'll see below. Now, the image is the new shape after the transformation. And just so you know, we go through and we use what is known as prime marks to denote that image. So you can see down here below that we have this triangle here in red with the prime marks. So that means triangle I prime, R prime, and T prime is the new shape, while the blue one was the original. And yes, if we do another transformation of that triangle, we would have I double prime, R double prime, and T double prime to denote that was the second transformation. Let's talk about these different transformations. The types of transformations that we look at are listed below. A translation is also known as a slide. It moves that figure without changing its orientation. So you can see that little triangle picture down below. It has moved from left to right or right to left, depending which one's the original. Its notation is pretty simple because it says you take any point x, y, you use the arrow to show that it moves, and then we show how we want to move each coordinate. So my little notation here is noting that I want to move my x coordinate by adding 4, and then my y coordinate by then subtracting 2. So it means moving to the right and moving down. And it could be add or it could be subtract with either of those coordinates. Now, when we talk about a flip is basically a reflection. And basically, the reflection can be over a horizontal or vertical line or the x or y axis. And just as a reminder, a horizontal line, also those hoi lines, is y equals some number. And a vertical line, a vux line, would be x equals that number. So again, down here, you can see I have this line of this shape down here, this triangle. The line of reflection would be between the two of those there. A rotation is just a fancy word for a turn. And a turn is going to be around the origin. It could be around any point, but we focus on the origin right here. We go through and we determine the degrees of that rotation by connecting a point and its image to the origin. We look at the angle that is created, and we're going to see that in the examples on the next page. And we also want to determine whether it's a clockwise or a counterclockwise rotation. And again, clockwise is in the direction of the clock and counter is the opposite. And a dilation is whenever something either grows or shrinks, sort of like how your eye might dilate if you go and flash a flashlight into it. The scale factor is determined by finding matching sides and comparing the image length over the original length. And when we do that, if the scale factor is greater than 1, that means the image was bigger. And if the scale factor was less than 1, the image was smaller. We're not going to get into negatives. So we're talking about basically a decimal number under 1. Let's see some examples. This first example in the top left is for a translation or a slide. And if we look at the original quadrilateral and pick one point, so for example, I'm looking at I, because every point will do the same thing. I can see that it went to the right 1 and then down 5. And all of the points do the same thing. So that means my notation for this guy is going to look like this, where I'm showing that every x coordinate goes through and has a move to the right of 1, while the y coordinates all go down 5. Hit pause and try the triangle after that. That triangle there went left 3 and down 2. And again, every coordinate the same thing. So left 3 and down 2. So my translation is showing x minus 3, comma, y minus 2. Let's talk about reflections. Now, with a reflection, this is whenever we can see that the shape has basically been flipped. And here we're looking for what is the line of reflection. So it has to be the halfway point between them. So there's the halfway point, and it's a vertical line, so that means it's a vux line. And so this is going to be x equals 1 because there's the origin and 1 would be right to the right of it. And if we look at the guy below, if you want to hit pause and give that a try, this guy has a line of reflection right there on the x-axis. That then means it's a hoi line, right? Because it's a horizontal line, and it's going to be y equals 0 there because it is right on top of the x-axis. Now, rotations are a little bit harder. Now, we're going to be rotating around the origin here, which means it's just our focal point. And that means we can go through and we can take any point and connect that original point to its image through the origin. And I'm going to use point D. So if I go from D to the origin and then from the origin then to the D prime, you can see I'm creating a straight line, which means it's 180 degrees. And with 180 degrees, the direction can be either clockwise or counterclockwise because it doesn't matter. However, when we look at that second example, and I'm going to use L because it's the closest, if I connect L original to the origin, and then from the origin to L prime, you can see I've created a 90-degree angle. And that 90-degree angle right here in the middle, right, is dependent on the direction. So going from my original, which is the one outlined in black, to the blue quadrilateral there, that is moving in the direction like this, which would be clockwise. If I wanted to move counterclockwise, in this direction, I would actually move 270 degrees counterclockwise. Either one would be correct. Lastly, let's talk about dilations. And remember, a dilation is when a shape grows or shrinks. And with a dilation, to determine the scale factor, I want to look at the image length over a matching original length for it. So the hard part is figuring out which one is the image, which one is the original. So if I look at for my triangles here, I'm looking to see that this one has the primes. I see it's bigger, so I'm expecting a scale factor to be bigger than 1. And so if I look at the lengths of the image just from A prime to B prime and see what that length of that is, the length of that image from A prime to B prime is 9, while from A to B over here in the original is going to be 3. So the scale factor for this guy here is 3, and it got bigger. When I look at this guy then to the right, the rectangles, again, I see A prime, B prime, D prime, and C prime is the smaller rectangle here compared to the large one. So I'm going to expect a scale factor that is going to be smaller then. And so the scale factor for this guy here, the image length of A prime to B prime there is a length of 2. Well, its corresponding length there is 6. And 2 divided by 6 then would have a scale factor length of 1/3. And that matches my expectation of it being a shrink.